Hi. You guys want to hear a funny story? You want to hear a funny story? I was wondering why was it कि कोई कुछ बोल नहीं रहा था. This is the second time this happened to me in the last 3-4 months, which is कि भाई I started the stream but it did not start, and which is why I'm on a random slide like this. I'm like भाई कोई कुछ बोल क्यों नहीं रहा है? You know, and I'm like, okay, cool, bro, I'll teach, I guess, you know, and I'm never late. So thanks for pinging me. I guess you should just ping me on Telegram if I'm even a minute late, because being late is not a part of my life. ठीक है, मैं किसी चीज में कभी भी late नहीं होता हूँ. So I started the session and I guess it didn't start. I clicked on go live and I started talking, right? And this is the second time this happened in the last 4-5 months. एक बार पहले भी हुआ था मेरे साथ नीट चैनल पे. Great. Now this also happened on the JEE channel, which is why I'm on a random slide and not the first slide ever. What's up? Good evening. Yeah, I'm so sorry for being late. I am late to you, right? By 10 minutes. So I'm really sorry about that. मैंने शुरू कर दिया था and for some reason yeah, did not realize कि it didn't happen. खैर रुको एक second. Let's go all the way back to where we started right here. ठीक है. What's up? Yeah, I should wait for your responses, you know. I should wait to see if you guys can hear and see me clearly. Anyway, I'm guessing you can hear and see me clearly now. Abhi theek hai. When Sai Kiran shouted late, I thought Sai bol raha tha he's late. I'm like, no, you're not late. And then I see Yuvraj saying ki sir aaj kafi late ho gaya. I'm like, oh bro, this is what is happening. I have, for some reason, this is not live right now. Yeah, really sorry guys. Khair. Really nice of all of you to be giving the answer over here. Okay, excellent work. Thank you so much. There was Yuvraj. There was और कौन थे यहाँ पे देख लेते हैं एक बार. This is the most important part for me, so we'll spend time on this. Yuvraj, Rek, Arman, and Nitya. Thank you so much for giving these answers. And Yuvraj special mention to this guy here for going through the pain to go with all the steps. Now, let me not write pain here. That looks weird, right? Steps, all the steps that he took to get to this. That's excellent. So the first question, yes, it's clear. Popat, yes. And I was just saying that I don't have a catchphrase, you know. Where I saw your comments, I don't have a catchphrase. I don't say things repeatedly, other than what's up or something, but that doesn't count. The electrical resistance of a column, blah, blah, blah. Diameter there 1 centimeter, length is 550 centimeters, and something else here. Calculate resistivity and conductivity. Now, all of you did this correctly, and in the interest of time, I'm just going to rush through this one a little bit. If you guys have doubts, you can ask me. R is rho L by A. This is the only formula that I want you to guys to remember in this part of this, in the first part of this ionic conductivity thing. Yeah, ionic conductance idea. So just using this formula, we're going to figure everything out. L यहाँ पे दिया हुआ है, area you will get by pi r square. You just need to be careful that r is 1 by 2 centimeter. Okay, that's the only thing you got to be careful about. ठीक है? And then you just substitute. You get value of resistivity. Kappa is just 1 by resistivity. Notice that units क्या है? It's per centimeter or in centimeters. Okay, not in meters. I know you've been told from the starting कि देखो दोस्तों, SI unit is meter and all that, but I told you be careful. It doesn't make sense to have a 1 meter का 1 meter can't even fit in this frame, right? Does it fit? Approximately, I think this is about a meter. I don't know. No, this is not a meter. This is still about 2.5 feet or maybe 3 feet. Okay, a meter makes no sense. Okay, in these units. So yeah, writing calculation in comments is actually a tough task. Yeah, right. I know, right, Rek? That's quite a tough task. Hats off to Yuvraj for doing that. Thank you for his effort. So all of you got this right. Excellent work. The next one was a conductance cell was filled with 0.2 molar KCl solution, which has specific conductance, some value given over here. Now, in both of these things, you'll notice that this concentration value did not make any difference till now, because we are talking just about the resistance or the conductance. हम लोग बस इसकी बात कर रहे हैं. Okay, यहाँ पे resistance कैसे निकालेंगे? Well, R is rho L by A, same formula, and then you say R is equal to 1 by kappa times G star, where G star is your good old cell constant. वही तो निकालना है. G star ही तो निकालना है. Multiply both of these things and you get 2.7 times 82 point something. तो थोड़ा सा approximate, but it's 3 into 8, right? It's approximately 3 into 80 into 10 power minus 3, and that's approximately 0.24. Now, if on getting that you can eliminate these two options, but इन दोनों के बीच में थोड़ा सा close competition है, तो you have to actually calculate. This is one of those questions where you can eliminate some options, but you still have to be careful when calculating this. Okay, and once you do that, you get the answer to be option B. ठीक है, चलो शुरू करते हैं आज का सेशन. Yeah, with the idea of molar conductivity. You'll notice that in all the calculations we did so far, all the calculations we did not talk about the concentration, right? Concentration हर सवाल में दिया था in the question before this and the question before that, but we didn't use it. where does the concentration idea matter at all? देखो, when you have a metal, like a metal rod or whatever, right? It's rigid. So its resistivity here, its resistivity here, its resistivity wherever it is, it's going to be the same, right? You're not even going to think about कि यार resistivity बदलेगी. But for a liquid, okay, if the concentration of ions, उसमें ज्यादा ions होंगे तो उसकी conductivity बढ़ जाएगी. अगर ions कम होंगे तो conductivity कम हो जाएगी. But think about it. Is it a good thing? अगर conductivity बढ़ जाए, is that a good thing? Yes or no? What do you think? Just let me know in the chat. मैंने ज्यादा concentration ज्यादा डाल दिया. Like I put a lot of ions in the solution. Is that a good thing? Good thing in the sense, does it aid in anything in the electrolysis process I'm looking at or whatever I'm trying to do? What does it help in? What do you guys think? Just a thought experiment, right? कि concentration बदलने से होता क्या है? सोच के बताइए थोड़ा सा. The formula all very simple in this, ठीक है? इसमें कोई टेंशन ही नहीं है. Formula very direct, straightforward सा chapter है. IIT के point of view से JEE, NEET, anything के point of view से it's straightforward. But what do you think is this? What do you think is the idea behind this? Can you please let me know in the comments? What are you thinking? Just gonna quickly check. Agar by chance this is bugging or you guys can still hear me. Yeah, you can hear me. Okay, sweet. हाँ, what do you guys think, guys? दोस्तों, बताइए. We are not stuck or anything, right? Writing calculation comments. Okay, is a tough task. See, this is defined as conductance of a solution that is there with exactly 1 mole of an electrolyte between 2 electrodes which are unit length apart. मतलब कि यहाँ पे 2 electrodes हैं and there is exactly 1 centimeter distance between them. Unit length, I'm taking it to be 1 centimeter, okay? Not 1 meter because you can't have 1 meter wala cheez. Conductivity increases, okay? Yeah, sure. Yuvraj and Rekha, you're right. I understand that conductivity increases. But उससे क्या होगा? What do you think? Physically speaking, okay, conductivity increases, so what? Does that mean electrolysis is faster? Or does that mean electrolysis is slower? Or कुछ और होता है? Have you thought about that? That's what I'm asking. We will try and explore those ideas. Okay. So kappa is defined as this expression. ये मैंने आपको last time derive करके बताया था कि kappa into V by L square, right? उल्टा बोला था कि kappa is basically proportional to 1 by V. This is what I had written down. Now I'm just telling you to take things on the other side. कि kappa times V by L square is equal to this conductance वाला idea. So at L equal to 1 and concentration is 1 mole, then you get lambda m equal to G, which means कि देखो कुछ तो यहाँ पे हम लोग अजीब कर रहे हैं, because all of these are talking about centimeter cube and centimeter में length, but your concentration term is defined as mole per liter. So you're going to have to do a little bit of conversion, and that's what leads to this 1000 wala factor. Okay, 1000 centimeter cube is equal to 1 liter. Okay. And I want everything in the same unit, either meter or centimeter. I'm choosing centimeter because that is a more sensible unit for our discussions. ठीक है? And this is why ये वाली unit आती है. Okay. Lambda m is kappa times 1000 by molarity. This 1000 comes because I'm converting liter to 1000 centimeter cube. That's all. ठीक है? क्योंकि molarity क्या होती है? It is mole per liter, and that liter I want to get to centimeter cube. That's it. So if you want the actual this thing is centimeter cube by 1 liter, ठीक है? And then this liter and this liter gets cancelled out. So what you're left with mole per centimeter cube. This unit आती है. You good? Yeah, you're right, Yuvraj. That's a formula. But why are we finding out molar conductivity? इसका point क्या है? इसका exact उल्टा होता है, right? When you do this, अच्छा ये 2 बार आ गया. And the interconjugate units and all is you want to convert one from the other. This is you got to multiply 10 power 4 वाला factor. ये figure out कर लिया. This is straightforward, right? Centimeter square से meter square में convert करना, this is okay. So why are we doing this? One more thing. एक तो molar conductivity था, दूसरा equivalent conductivity का idea. Yeah, equivalent conductivity या फिर equivalent conductance. This you're talking about 1 gram equivalent of electrolyte. What is 1 gram equivalent? Something that reacts with 1 mole of electrons. Okay, and this is similar to normality. The only difference now is the denominator will have n. That's it. So lambda equivalent is going to be equal to kappa times 1000 by normality. Okay, and as usual, you will have the same, what do you call it? When we are trying to change the unit, you'll have the 10 power 4 wala factor between them, and the relation between these two मग करने वाली बात नहीं है. Okay, please don't mug this. Derive it if you have to. Write down this expression that lambda m is equal to kappa by concentration in moles. Lambda equivalent is equal to kappa by n. So from this, if you extend this, you will get lambda equivalent is lambda m by n factor, which is the exact opposite of normality and molarity. It makes sense. Normality is molarity into n. यही चीज मैं यहां पे यूज कर रहा हूं. That's all I'm using. ठीक है. So equivalent conductivity is lower than molar conductivity. Could be a theoretical question that is asked. JEE में आजकल उनका they've started doing that, right? They'll give 4 statements. इनमें से कितने correct हैं? They'll do that sort of a thing, right? Okay. Back to the question. Why is it that we are finding out something called molar conductivity or equivalent conductivity? ठीक है. Think about this. Keep that at the back of mind. एक छोटा सवाल पहले कर लेते हैं. Then we'll address this question in the second half of this, maybe around 10 minutes or so. The equivalent conductance of 0.1 normal solution of MgCl2 is some value. At 25 degrees Celsius, a cell with electrodes that have 1.5 centimeter in surface area and 0.5 centimeter apart are filled with some same concentration solution. What current will flow? Wow, current. What current will flow? Now we're getting close to the end. What current will flow when the potential difference between the electrodes is 5 volts? देखो, yeah. When you put 5 volts, then you can get resistance. V equal to IR use करो. I know. I know V equal to IR is only Ohm's law जो follow करता है उसी के लिए है. But अभी के लिए assume that V equal to IR. ठीक है. That is something you will have to assume to be able to solve this question. उसको assume करो and try this question. Try this out, please. Any doubts on how to start this, or are you guys good? Please let me know. There's a bit of an overlap that I just removed there. That's what I was doing. दोस्तों, how's it going? How's the question? Is it hard? Is it doable? What do you guys think? मुश्किल है क्या? You want me to give you a heads up or something, like a bit of a pick me up? Trying? Okay, try karo. I can give you the first set of equations, so to speak. All the equations you need to solve this, right? That'll do 90% of your work. So keep trying until I give you that. V equal to IR, R equal to 1 by kappa times L by A. These are equations. This equation you know from, like, I don't know, 9th grade or something, 9th or 10th, right? This also you know from 10th. Only difference is instead of rho, I'm saying 1 by kappa. Yeah, equation is new. This equation is what I've taught you today, theoretically. But I'm sure you already know this equation. ठीक है? यहाँ पे normality. अब इन तीनों को combine करो and get I and get voltage. है ना? Because I ही निकालना है, right? Voltage दिया हुआ है, तो I is equal to R by V, right? R by E नहीं, sorry, V by R. What am I saying? I is equal to V by R. Like, wait, that sounds weird. That sounds funny. That's not right. I is V by R. 160 ampere says Sai. Sai, cross check करो आंसर को. You know how big a current 160 ampere is? Okay. I'm not Sai ने तुरंत ट्रैक कर दिया. But देखो, जब तुम्हारे वाइल्ड आंसर्स आते हैं ना, उसको चेक किया करो. आपके फोन में what is the current that charges your phone? कभी सोचा है? कुछ सोचने की क्या जरूरत है? उसको निकाल के देख लेते हैं. I hope nothing goes off. Oh, thank God. क्या लिखा है इसमें? कहाँ लिखा है? Dude, I need glasses. Too tiny. Anyway, I kind of know. I was just doing this dramatic things to check. But I think it's something like 1.5 amp का बहुत चार्ज होती है, तो फास्ट चार्ज होगी तो 10 amps 15 amps हो गया. नहीं, आजकल तो क्या लोग जो है 20 amp पे भी चार्ज कर रहे हैं, 30 amp पे भी चार्ज कर रहे हैं. That's fast charging. It's really fast charging. Okay. So 160 amps is not happening unless you're trying to charge a car. I think a car would have a charging of 160 amps, and that's not going to be produced by a 0.1 normal solution of MgCl2. I'm not messing with Sai. I'm just saying कि you should know what physically that means. 160 amp का मतलब क्या है? That was just an interesting thing, right? There's electricity all around you, right? Everything that you do is mostly with DC stuff. All electronics are with DC current. Okay, your computers, your cell phone chargers, everything runs on DC. It converts AC to DC. Battery से चलता है, जो भी करता है. Anything runs with batteries, mostly DC. खैर, why am I saying DC? Because this is obviously DC, right? ये एक डायरेक्शन में जा रहा है. दोस्तों, this idea of DC AC you're able to follow, right? This is DC current. There's no doubt there. DC मतलब direct current, I know. This is DC. Okay. 0.145, rec. I like it. Because it sounds like it could be correct. Maybe it is. This is a more reasonable question, a reasonable number. ठीक है? अब concentration of 0.1 normal की, so this is what you get. Okay. Simple सा hack करो इसको, I equal to V by R, which is V by L by A into kappa. Then what do you do? ये kappa क्या है? Lambda equivalent into N by 1000. अब बस substitute तो करना है और क्या करना है? कुछ बचा है? Substitute करना है directly, right? V is 5. L by A is 0.5 and again यहाँ पे 1.5 और कुछ भी दिया हुआ है. हाँ, this is 0.5 by 1.5. Sorry, this is the L by A. Okay, 97.1 is the क्या बोलते हैं lambda equivalent and into 0.1 क्यों किया? अच्छा, this is the normality. हाँ, हो तो गया. तो बचा क्या? ये दोनों क्रॉस आउट करो तो ये 15 हो गया. तो इज बेसिकली 15 into 97.1. No, it's 15 into 9.7 divided by 1000. That is what it will be. So approximately 150 by 1000, which is 0.15. Yeah, great. Right? I think your answer is correct. Absolutely. Do you guys agree? Sai, क्या हुआ? 160 कैसे आया? Did you forget the 1000? I know what you did. You did something like 10 into 1 point. You did some approximation and you forgot the 1000, I think. Sai, is that correct? Is that what happened there? Let me know. Good job, Rek. We're going to move on to a little bit more theory. Okay, the theory is direct. Koi doubt hai to please tell me. I'm not in any kind of hurry whatsoever. You tell me if koi doubt hai, I'll help you out with it. But I feel that it काफी direct hai. There are some equations involved and just शुरुआत में थोड़ा सोचना पड़ता है करना क्या है. Once you do that, then it's direct, yeah. I know I've said direct like 5 times in the last minute. Okay, sweet. Now, this idea is probably the most important idea of this part of the chapter, right? Yeah. Okay, great. Variation of conductivity and molar conductivity with concentration. Now, how does concentration change everything? You guys are saying conductivity, बढ़ जाएगी. I agree with you. But they both change. Okay, in what way do they change? Let's look at it. पहले conductivity explain करते हैं. If I increase the concentration, if I decrease the concentration, then conductivity decreases, which means कि dilution मैंने बढ़ाया. And this for both strong and weak electrolyte. एक मिनट, ये strong और weak electrolyte कहाँ से आया? What is this strong and weak electrolyte? You know, right? Equilibrium idea से. Strong electrolyte is I put 1 mole. If it's 1:1 electrolyte, if I have HCl, let's assume it's a 1:1 electrolyte. What is a 1:1 electrolyte? We'll see. Then it will give you, अगर मैंने 1 mole डाला, it will give you 1 mole of cations, 1 mole of anions. That's strong. Weak is not 1, something lower than 1, right? Maybe it gives you lot smaller, like 1 by 100 moles or 1 by 1000 moles or something like that. You know this. So, concentration come, conductivity come. This is mole per liter. This depends on mole. Conductivity depends on mole per liter. That's what we're trying to say here. So, अगर ये volume बढ़ गया, तो conductivity कम हो जाएगी. This is something I told you last class also, right? And which is what you also agreed with. Okay. Molar conductivity, the ratio of conductivity by concentration, this decreases when you increase the concentration. And this increases on dilution. Okay, sure. Well, you've defined a term. अपने मन से मनगढ़ंत कोई term बना दिया, right? We made up our own term. We said, boss, कि this is something called kappa by m, right? Molarity times 1000. हमने इसको define ऐसे किया है. तो obvious है कि हमने ऐसे define किया तो ठीक है. Concentration बढ़ाएंगे तो कम हो जाएगी value. Concentration कम करेंगे तो बढ़ जाएगी. What does this mean? What does this mean? We'll explore this in strong and weak electrolytes differently. Okay. And how does it matter? In weak electrolytes, it's a little, weird. Things are a little weird. At really high concentration, weak electrolytes like acetic acid, they have a very low degree of dissociation. Ring any bells? What is degree of dissociation? ये सब idea आप जानते हैं? I just want to show of hands in the comments. How many of you already know all this and this is a repetition? You just want to do questions? और आपको कुछ theory में भी doubt है? Which of the two? Like, are you here for? If you're here for questions, हम लोग वो करेंगे detail में Sunday को. If you're here for the theory, this is what we're doing right now. Alpha, okay. Yeah, we'll continue with this. Yuvraj saying alpha. Yeah. So, okay, cool. At infinite dilution, matlab ki when you have really dilute solution, alpha tends to 1. We have seen this when we did equilibrium, right? When we said that C into 1 minus alpha, if you remember this, right? If you take a 1:1, this thing, you get C alpha square by C into 1 minus alpha. C यहाँ से हटा देते हैं. So we say कि अच्छा, if alpha is really small, alpha is very much lower than 1, then you just remove this term and then you say K is almost equal to this. Right? We did all of those things. Anyway, that was the case when alpha was really small. So at infinite dilution, alpha is exact उसका opposite होता है. Alpha tends to 1. This is also something you studied in equilibrium. Do you remember this at all, or is this new? You're here for revision. Okay, revision, theory. Poonam, what's up? Okay, sweet, theory. Okay, we'll go with theory. So as you dilute ionic solutions, the degree of dissociation alpha of the electrolyte increases. Now you can put numbers to this and check this out. ये equilibrium session में मैंने NEET में detail में किया है, but you can also try it. वो पूरे equilibrium के chapters हैं. Put numbers ना. आप किसी take any K, take a random K to be 10 power minus 5. Take 1 mole concentration. ठीक है. Take 0.1. Take 0.001. Take take 10 power minus 4 molar. Concentration of what? Concentration of HA. And see alpha में क्या change होता है. You do this on your own. That's the only way you'll remember this. कि alpha की वैल्यू बढ़ती जाती है. ठीक है. Anyway, what does that mean? Yeah. At low concentration, there is increase in number of ions per unit volume. Obviously, अगर मैं concentration कम करूं, तो ions थोड़ी ना बढ़ेंगे. But ions per unit volume will increase. And that matters because what is happening in water or basically जो पानी में जो हो रहा है is literally ions in the water, right? And if you do this, then there's a very big increase in molar conductance. You see this. This here, this section is when alpha is much lower than 1. Ulta bola maine. Sorry. Concentration is very small, not alpha. And alpha is, gets close to 1. Okay? And we are plotting root C versus lambda m here for a reason. I'll tell you why we're plotting root C, because when you take a look at strong electrolytes, there was a relationship that was obtained with root C. इसलिए हम लोग यहाँ root C plot कर रहे हैं. Sometimes students ask me, भाई, why are you plotting, this thing lambda m versus root C? Why not just C? Even for weak electrolytes, ताकि दोनों को हम लोग compare कर सकें. We want to be able to compare a weak and a strong electrolyte. Okay? ये class 11 में नहीं है तो पूनम ये 12th का है. You're right. Poonam, this chapter is from 12th grade. The equilibrium ideas I'm using, those are from 11th. Poonam, I hope that made sense. Cool. Is this graph okay, folks? Do you follow this graph? Is there anything that you want to talk about in this graph? Anything that you don't understand in this graph, please tell me. Because if you do graphs, then JEE Advanced बहुत आसानी से हो जाएगा. If you skip graphs, JEE Advanced is going to be very hard. I'm just being straight with you. If I was saying he understands it, Rec, anybody else here who wants an explanation on this graph? Anything more that you guys want to chat about on this? Yeah? Sai Nand, good evening. I think I missed your messages earlier. Apologies. Samyak, I think wo bhag gaye, because let me just ping on that. Hey, hello Ayush. Hey, I think I started a couple of minutes late. It was because I didn't realize that I had not clicked on the go live button, or I clicked and it did not work. So it's live right now. Is that a hyperbola? Interesting. So if it were a hyperbola, then it would form something like xy equal to c, right? Let me get back to you on that. That's a beautiful question, Sai. Is it a hyperbola? I don't know of the exact equation that governs this. Hey Ankit, what's up? Okay. Which is why I can't comment on the fact that it is a hyperbola or not. Okay. Yeah. But I don't think it is, right? Because the concentration can the root CRI. So maybe, no, what I've drawn, what I'm saying, xy equal to c is a rectangle hyperbola. Maybe it's some other hyperbola. Could be. But this is asymptotic. Looks like this is asymptotic. Looks like this is asymptotic as well. Maybe. Let's see. Okay. Sweet. What happens with strong electrolytes? As you dilute the solution, lambda increases, but not by that much. Itna zyada nahi, but it increases. Okay. But here is the catch. Lambda of a strong electrolyte is going to be more than a weak electrolyte almost at all concentrations. ठीक है? क्यों? क्योंकि strong electrolytes are fully ionized always. So there is no abrupt change in the number of ions with dilution. ठीक है? In a concentration solution, the problem is, and this is, listen to this carefully. In concentrated solutions, there's a strong attraction between oppositely charged ions. Yeah, H plus, H नहीं लगता. Let's write AB, right? So A plus and B minus. If the concentration is high, they'll come close together and उनकी mobility कम हो जाती है. Ions की mobility NCERT में नहीं है, so we'll not go into detail. If you want to read up on mobility, you can. But mobility just says कि if the ion is large, अगर बड़ा ion है तो धीरे move करेगा, और अगर ज्यादा ions है तो they will repel each other a lot or they will attract each other a lot, and then hence the movement will get hindered. Okay, so it slows down. Also size. Okay, so if size is high, mobility is low. This is important. I'll tell you why. We'll look at a question and उसमें समझ आएगा. ठीक है. When you dilute stuff, the distance between the ions increases and there's a decrease in interionic attractions, and hence there's a gradual increase in the molar conductivity of solution, and this is what we're going to see in a graph very, very quickly. ठीक है. As the concentration approaches zero, which means the concentration is very, very much lower than 1, molar conductivity is known as limiting molar conductivity. मतलब you assume कि it's almost behaving like gas particles that are really, really far apart and not in the influence of one another, and this is known as lambda infinity. Okay, and if you take it as standard states, if you take it as standard states, this is lambda naught infinity. ठीक है, cool. Okay, Yuvraj. Okay, x square by a square minus y square v square equal to 1. Collisions. All right, sweet. All right. So the equation that governs strong electrolytes is this. I told you standard conditions में not लगा दो, right? Limiting molar conductivity, and this is the molar conductivity at any other sort of given what you call it conditions. ठीक है? This is what the expression looks like on a graph. And remember, again, I'm plotting root C here. Yeah, lambda versus root C. And this intercept is lambda naught. This slope is negative A. What is this slope? This is the same as y equal to negative m times x and c. So ये c हो गया आपका intercept, right? Negative m is basically your slope. Okay. Now what is this A? अगर you have a 1:1 electrolyte, okay, whether it is KCl or NaNO3 or whatever, this A value is the same. Okay. So this value of constant A, it depends on the solvent and a temperature. तो हम लोग ज्यादातर पानी में ही चीजें कर रहे हैं. So it's going to be the same. Type of electrolyte, मतलब is it 1:1 or 2:1 or 1:2? What is 1:1, 2:1? 1:1 is KCl NaNO3. 2:1 will be Mg गलत ले लिया. Let's say Na2SO4. जहाँ पे एक मोल ड्रॉप करो तो वो 2 मोल पॉजिटिव आयंस को देगा, 1 मोल नेगेटिव आयंस को देगा. What is 1:2? MgCl2. Right? You follow, right? समझ में आ रहा है? What is 1:1, 1:2 and all that? यहाँ पे दिया हुआ है. ठीक है, फिर से अच्छी हैंडराइटिंग. Sai Kiran, infinite dilution does not mean infinite volume. It just means ions are really far apart. Concentration is low. I understand what you're saying, Sai. You can just put very few ions, right? How do you lower the concentration? या तो volume बहुत ज्यादा कर दो, या तो concentration, या तो moles कम कर दो. I'm just saying moles कम कर दो. That's all. ठीक है? Hey, Ram Bhavesh ji. Shruti, how are you doing? Sorry, Srishti. An electrolyte at a particular type of particular type all have the same A. Type मतलब क्या? वही था 1:1. All 1:1, all will have the same A. That's what we were talking about. Interestingly, these are a little bit of extra information, maybe not in NCERT, but just some extra information. अगर dielectric constant बढ़ता है तो A की वैल्यू कम होती है. What is dielectric constant? Water का AT है, right? The amount of charge something can hold before it breaks down stuff. Physics की ideal. Studies in physics. Yeah. Temperature बढ़ता है तो viscosity, I mean temperature के साथ A increases, viscosity at A decreases. Yeah. Sorry. As temperature increases, A decreases. As viscosity decreases, A also decreases. ठीक है? Extra stuff. Yeah, I know, Yuvraj. Beautiful stuff. We have an excellent art team that made all of these things. You don't have to write all these notes down. I'll give them to you. आराम से पढ़ सकते हो. Some of it is a little bit above and beyond NCERT, but most of it are things that you'll be able to use आराम से without any extra stuff. ठीक है? Now this is why we need all of this lambda वाला ideas, right? ये हम लोग extrapolation से figure out कर सकते हैं, okay? Because you got a straightforward graph. But for weak electrolytes, you can't. Okay, they've got such a strange graph. When you do the whole lambda versus root C वाला graph, strong electrolytes are here and weak are here. तो strong का आप लोग figure out कर सकते हो, right? It'll go all the way here and this is the intercept and this itself is the value of lambda naught m, right? But weak का करना थोड़ा मुश्किल है. So you use the strong to get to weak. That's the application. We'll look at it very soon. पहले एक सवाल करते हैं. Let's look at a quick question. On increasing dilution, What of these will increase? Which of these will increase? Equivalent conductivity, conductivity, molar conductivity, yeah, all of these. बताइए, what do you think? What do you think? इन चारों में से क्या बढ़ेगा? क्या बढ़ेगा? Which will increase? Or increasing dilution. Sai saying D, all of these, okay. Sai बोल रहे हैं D. What do you guys think? It can be more than one correct, okay. It does not have to be one answer correct only. Shrishti, Bhavesh, what do you guys think? Yuvraj, Rek, Ankit? Rek is saying A and C, okay. Rek goes with A and C, all right. What about the rest of you? क्या सोच रहे हैं आप? See, or increasing dilution मतलब you increase volume, right? And you remember, I've told you that last class also, ये घट जाता है. So when I increase volume, then hold on. If I increase volume, then K will decrease. हाँ, kappa तो कम हो जाएगा. Conductivity will decrease, so this is not the right answer. And yeah, equivalent conductivity and molar conductivity. Molar conductivity क्या होता है? It's simply kappa divided by m into 1000, right? और dilution मतलब molarity कम हो रही है, denominator is falling, मतलब lambda m will increase. Similarly, lambda EQ also will increase. So ये दोनों सही है. So A and C are the right answer. Good job, Rick. Good job. Sai has retracted their answer. अगला सवाल. A graph of molar conductivity. Good job, Yuvraj. A graph of molar conductivity of three electrolytes, NaCl, HCl, and NH4OH is plotted against root C. Which of the following options is correct? सोच के बताओ. I am plotting three things: NaCl, HCl, and H4OH. So out of these, which of these matches this? These four things over here. सोच के देखो. So excellent question. Excellent question. I can see where you can get confused. Hey Muskan, what's up? We can eliminate some options right away, I feel, right? It is very clear that 3 is a weak electrolyte. Now, what of इसमें से weak तो सिर्फ NH4OH ही दिख रहा है. So it looks like it has to be either A or C, right? It has to be either A or C. It cannot be B, it cannot be D. हाँ देखो इसलिए साई बोल रहे हैं A और युवराज बोल रहे हैं C. ठीक है. Sai, do you want to tell us why do you think it's A? Welcome Muskan. और Sai, युवराज, why do you think it's C? आपको क्यों क्या लगता है? What do you guys think? See, H plus is a really small ion, so it can move very easily. So it must have a high conductivity. It's just a hypothetical idea that I'm throwing away. Na plus थोड़ा बड़ा है, maybe उसका conductivity कम होगी. I haven't taught you this explicitly, but when you take things really far apart, then you can add up their conductivities. Okay, so HCl की conductivity, molar conductivity will be higher than that of NaCl की molar conductivity. Every time I said conductivity in the last 30 seconds was molar conductivity. Okay, which is why the answer is going to be option C. मतलब इसकी सबसे ज़्यादा फिर ये और फिर ये. ठीक है? Cool? Yeah. The conductivity मत बोल युवराज, molar conductivity बोल. Let's say molar conductivity. ठीक है? All right. Sweet. Excellent work. Excellent work. आगे बढ़ा जाए. आगे बढ़ते हैं. So ionic mobility, although I said I'm not going to go into some detail about this, yeah, it's just defined as the speed of an ion per unit electric field. Potential gradient is denoted by this symbol. Since it's not really in your syllabus, I think we'll just ditch it. Let's move on to Kohlrausch GK laws. Kohlrausch's law, the second thing that we're supposed to study in today's session. It's okay, Sai, कोई tension नहीं है, कोई tension नहीं है. This will give you impetus to read, ना? इसके बाद पढ़ना ही पड़ेगा अगर ये सवाल करने तो. एनसीईआरटी के जो सब्जेक्टिव क्वेश्चन है रियली गुड. आई नो समटाइम्स एनसीईआरटी पढ़ने में मुश्किल होती है. आई कीप मेकिंग रील्स टेलिंग यू टू रीड एनसीईआरटी बिकॉज़ आई रियली वांट यू टू रीड एनसीईआरटी. दैट्स अ रियली इजी वे ऑफ गेटिंग मार्क्स इन जेईई एंड एडवांस्ड. व्हाट इज दिस कोलरॉश लॉ? अभी मैंने बोला था ना, एंड रेक आल्सो वाज सेइंग समथिंग, राइट? नो, युवराज वाज सेइंग समथिंग. स्मॉलर द साइज, मोर द कंडक्टिविटी, मोलर कंडक्टिविटी. अक्षरा, व्हाट्स हैपनिंग? Kohlrausch, he did something fascinating. He said that, look, he figured out some sort of a relationship between a lot of common strong electrolytes. उसने figure out किया the difference, something fascinating. In lambda naught m of electrolytes NaX and Kx for any x is nearly constant. NaX मतलब x is a halogen, right? in this case, or it could be just basically any anion. Let's assume that it's a halogen, like Cl. So he said that NaCl, KCl minus NaCl and KBr minus NABr, okay, in दोनों की conductivity was constant, and it was also equal to Ki minus NaI. मतलब कि it's almost like कि इसकी conductivity उसकी conductivity minus की, so it is somehow cancelling out the anions also, because the anions are the same. Similarly, he also did this with this C here, NaBr and NaCl. In this case, ulta kiya. Now in this case, he's like, chalo, maybe it's not an anion thing. Let's try with keeping the cation constant. So यहाँ पे cation same रखा है, Na रखा है, and even then he got the same result. What does this mean? This means that it looks like these guys are being cancelled out. जो common चीजें वो cancel out हो रही हैं. यहाँ पे Na और यहाँ पे K और यहाँ पे Cl common था, Br common था, I common था. So it looks like lambda naught of K minus lambda naught of Na is 23.4. That is what it's looking like. And यहाँ पे it's looking like lambda naught of Br minus lambda naught of Cl is 1.8. But they're almost the same. Lambda of Br and Cl are almost the same. ठीक है? Sweet. Weird. Questions are good. NCERT की theory boring है, but उसी theory से marks मिलते हैं दोस्त. An infinite dilution or near zero concentration when this is 100%, each ion makes a definite contribution. मतलब कि एक ion दूसरे ion के पास नहीं आता है. So उसका effect, उसका खुद का effect, its own effect है. Okay. And they contribute towards molar conductivity irrespective of the nature of the other ion. इतने अंग्रेजी क्या मतलब हुआ? You can add them up, boss. You can add them up, but make sure you take care of the stoichiometry of the salt. Okay. जो भी salt आप पानी में डाल रहे हो, it has to be soluble. That is the first thing. ये soluble तो है. दूसरी चीज stoichiometry का आप ध्यान रखो. So molar conductivity will be equal to lambda. Now देखो छोटा वाला lambda आ गया. Lambda of this ion plus lambda of this ion. Also number of ions. Obviously ना, है ना? Number तो count करेगा ही. Sure. I'm saying that the ions are separate. They have their own effect. But अगर ions ज्यादा होंगे तो उसकी conductivity ज्यादा होगी. As simple as that. है ना? ठीक है? Cool. Same thermo वाला काम है. हाँ, Hess law वाला, right? Hess law वाला idea. So, for example, what will this be? This is simply going to be lambda naught of what do you call it? 2 times lambda naught of Al3 plus 3 times lambda naught of SO4 2 minus. बस यही है. ठीक है? खत्म. This is what Kohlrausch said. खत्म हो गया session. वहाँ enthalpy, यहाँ molar conductivity. Yes, same thermo. What happens for finite dilution? Nityashri, thank you for answering the homework questions. We did showcase those in the starting. What happens at finite dilution? Life becomes complicated, Nityashri. See, in that case, you use a potentiometer and you try and see what's happening. It's a little, you basically figure things out experimentally and you don't have equations that tell you things that clearly. That's the short of it. If you want to know more, just whatever, the question is specifically, finite dilution में क्या होता है? Look it up on chemistry stack exchange. That's a beautiful site, but let me give you a warning, okay? It goes way beyond anything that you and I will ever think of, but it's a nice idea if you want to just know, hey, hota kya hai? If you're curious, you want to check it out. Nothing related to JEE. What happens in finite dilution? Put it up here and you'll get answers. It's mostly experimental stuff. Okay? Cool. Okay. So you can add stuff up. And as usual, the lambda naught equivalent here is lambda naught m by n factor. This is still there. So this expression holds good for lambda naught equivalent also. Lambda naught equivalent also is going to be equal to sum of this plus sum of this. Now this is fascinating. Okay. It's different from this here. यहाँ पे क्या था? देखो, when you're doing lambda naught m, just like जब आप मोल कॉन्सेप्ट में कर रहे हो, बहुत हेडेक होता है ना बैलेंस करना. आपको बैलेंस नहीं करना पड़ता है when you use the concept of equivalence. Similarly, and this is something that is very interesting. Similarly, when we use lambda equivalent, you don't have to worry about x and y. Why? Because lambda naught equivalent is lambda naught m divided by this n factor. Okay. Do you understand this, or is this a little confusing? Hey Gopi, Nitya, I know I didn't answer your question because I don't have an answer for you right now. If you are on Telegram, ping me on I Teach Chem and I'll read it up and I'll give you stuff that we can digest at our level. ठीक है, ping me there on Telegram or on Discord. So this is the funky expression that I get. Look at it. This is beautiful. I don't have to worry about whether I missed a 2 or a 3. यहाँ पे 3 or that. I don't remember it. I don't remember it. Okay? Yeah? You see that? Exactly. N factor संभाल लेगा. I like what Yuvraj says. N factor संभाल लेगा. So what are the application of these Kohlrausch law? मैं आपको hint दिया था, right? The first and the most awesome thing is to calculate the lambda naught M of weak electrolytes. Because I can't figure it out, right? Look at this. It does some weird stuff. It's like this. How do I get lambda naught M key value? Right? This I can extrapolate back and get, dot, dot, dot. I can get lambda naught M. But for weak में क्या करूँ मैं? I can't do it this way. So I do it with experiments. How do I do it? From the individual ions. If I take a weak electrolyte like say CH3COH, ये weak है, right? ये हमारा दोस्त weak है. I will assume that CH3COH was made from some strong electrolytes. Because I'm shameless, we will do it. ठीक है? At infinite dilution, this goes to completion. Single head arrow मतलब this goes to completion. Alpha equal to 1. Okay? यही तो मतलब है ना? You understand this? I have reduced the double head arrow to a single headed arrow. क्योंकि I'm assuming, भाई, this one goes to completion. जब concentration हो गया बहुत कम. So now, if I do this, then I can say कि boss, lambda naught of this is going to be simply lambda naught of CH3CO minus plus lambda naught of H plus. अब now that I've got into this, अब आया ऊंट पहाड़ के नीचे, then I can play around with some known quantities and from there I can subtract, add and do funky things. What am I doing? See, I don't know what is for CH3CO minus, I don't know what is for H plus, but I know HCl and I know CH3CONA. Both of these are strong electrolytes. ये आपको equilibrium से याद आ रहा है कि why is it that CH3CONA is a strong electrolyte? It's a salt, right? CH3CONA is a salt. What? A weak acid in a strong base. So थोड़ा बहुत याद आ रहा है कि नहीं? Right? So I add both of these and I subtract NaCl. What does this mean? H plus, Cl minus, plus CH3CO minus, plus Na plus, minus Na plus, minus Cl minus. सब चीज का लैम्डा. ठीक है, मैं लैम्डा बार बार लिख नहीं रहा हूं. लैम्डा नॉट M basically. So in this you've got Na plus gets cancelled out, Cl minus cancel out, and what you have then in the end is this, which is what we wanted in the first place. Ta-da! This is the first and the most beautiful application of Kohlrausch law, to be able to figure out weak electrolytes का lambda naught value क्या है. ठीक है? Muskan is saying something. Let me read her comment. I missed her comment. एक second. Yuvraj also saying something. Hey India, molar conductivity weak electrolyte because it's not possible. Fine. Ah, great. Water infinite dilution can be obtained from the knowledge of molar conductivity infinite dilution of sodium hydroxide. अरे वाह! Yes, Muskan, absolutely right. 100%. सही है, सही है. But water, huh? Water is interesting. पानी, पानी. अच्छा, ठीक है, ठीक है. Cool. I'll take your word for it. Sounds interesting. But पानी, पानी का भी होता है क्या? In theory, what you're saying is right, but I'll have to read up on that. If that's actually, because it will be a very small value. Water का molar conductivity क्या होगा? Sounds like an interesting thing. Khair, anyway, so अगर किसी का भी common ion है, limiting molar conductivity of the ion is the same of all of these electrolytes. Okay, अगर common ion है तो, for example, ये H plus is same in both this and this. Why? Because I'm going at infinite dilution, guys. ये मत सोचना कि भाई ये तो weak है और ये strong है तो ये पूरा H plus देगा नहीं देगा. Remember, at infinite dilution, alpha equal to 1. Okay, ठीक है. एक सवाल लेते हैं. Let's take a question. Calculate lambda naught M and lambda equivalent of oxalic acid given that, पढ़ लो यार. But ध्यान से पढ़ो. दो वैल्यू दी है lambda equivalent की, एक वैल्यू दी है lambda naught M की. ओके, ध्यान से पढ़ो और सोचो इसको कैसे करना है. It's a very nice question. It's a very nice question. Nice because it tests everything that we have learned so far conceptually. इसलिए मैं बोल रहा हूं कि मुझे लगता है कि ये सही सवाल है. Try it out. And if you get this, you'll be like, ये तो पूरा चैप्टर हो ही गया practically, है ना? Where are we at? We are here. Okay. After this, we have just like maybe 5 odd minutes of stuff to do and we'll be done with this आज का session. Hold on. Yeah. 650, 600, 850. ठीक है. साई आप किस चीज की बात कर रहे हो? इंडिया, आप किस चीज की बात कर रहे हो? आई वॉन्ट टू थिंग्स, तो आंसर दो आपको देने चाहिए, लैम्डा नॉट एम एंड लैम्डा नॉट इक्विवेलेंट। और ध्यान से करो, ये है सोडियम ऑक्सलेट का, ये है सोडियम सल्फेट का, ये है H2SO4 का, ओके। और हमको निकालना है ऑक्सैलिक एसिड का, विच इज अ वीक एसिड। व्हाट इज ऑक्सैलिक एसिड? H2C2O4, ठीक है, इसका हमको निकालना है। Sai is saying lambda not m is 650. India maybe is doing 850 of the same thing. India, I know what you did. I think आपने फॉर्मूला उल्टा लगा दिया फॉर लैम्डा नॉट एम एंड लैम्डा इक्विवेलेंट का रिलेशनशिप, ठीक है। व्हाट वाज द रिलेशनशिप बिटवीन देम? फर्स्ट प्रिंसिपल्स, लैम्डा नॉट एम इज kappa by molarity, lambda equivalent is kappa by normality, and normality is n factor into molarity. ये तीन चीज ध्यान से लिखो, then you know the relationship between lambda naught m and lambda naught equivalent. What do you guys think? Anybody else here? Yuvraj, Rek, Muskan, do you want to give me the answer to this one? India, thanks for coming in, and giving me answer quickly, but एक बार आप चेक करो। साई, आप भी थोड़ा चेक करो। Divyansh also giving 650. Yuvraj, giving me an answer that I like more than the other ones right now. But thank you everybody else for giving us the answer as well. Divyansh is saying 650. No, Divyansh is saying 650, okay. Sai is also saying 650. India is saying 850. And Yuvraj is giving us the answer of 300 and 600. Yeah, बस ध्यान से करने वाली चीज है. So, lambda naught equivalent or lambda naught m, how do you get them? Okay, for both these expressions, you will have these things in the mix, right? ये आपको इसका पूरा निकालना पड़ेगा. But इसका निकालना, lambda naught equivalent is easier. Why? Because lambda naught equivalent does not care about the number. Okay, does not care कितने ions हैं. तो lambda naught equivalent of H2SO4 is simply 700 by 2. Okay, which is 350. Why is it 700 by 2? ये पूरा मैंने राम कहानियां लिख दी है ना, है ना? तो lambda naught m by n factor will be lambda naught equivalent. You want me to write that again? I can write that again. Lambda naught equivalent is lambda naught m divided by n factor. That's all we used over here. उसके बाद lambda naught equivalent of H2C2O4 is what? 350, which is this guy here. I have added H2SO4, right? Minus Na2SO4 minus 450. This is minus Na2SO4. फिर से लिख देता हूँ, H2SO4 minus Na2SO4 plus क्या? Plus Na2C2O4, है ना? That you get to be 300. And from this expression, you get lambda naught m to be 600. Cool? All right? Muskan, 650. Okay. How did you guys get 650 and 850? I think आप लोगों ने जल्दी में ये ऑर्डर आगे पीछे कर दिया होगा. But do you follow? अभी हमने जो किया, is this okay? Is this all right, folks? Yeah, please let me know. तो lambda not 600, not 650. ये क्या कर दिया? 600 पूरा वो क्या है? What is the unit? It would be Siemens centimeter square per mole. This is lambda m, and lambda naught equivalent is 300 Siemens centimeter square per equivalent. Sir, 600, okay. Clear? Wu Shang clan. All good? Shall we move on? Rek? Yeah, good stuff. आगे बढ़ा जाए? Okay, sweet. Last idea for today is another application of Kohlrausch law, which is the determination of degree of dissociation and the dissociation constant Ka. इसमें भी सवाल आ जाते हैं कभी-कभी. And see, the Ka expression is given by this. Okay. And lambda naught m is proportional to degree of ionization or dissociation. ठीक है? You know that कि Ka value is, simply this expression here. Ka is also going to be equal to C alpha square 1 minus alpha. Yeah, cancelling stuff out. So, if alpha is proportional to lambda m, I'm going to take a leap of faith and say that this alpha is going to be equal to lambda m divided by lambda infinity. ठीक है? So, with that, you get Ka in terms of this whole concept of alpha in this derivation here, and you can write this down very simply as Ka is this way. ठीक है? Just using this, you should be able to solve some very easy questions. This is what अगर इसमें आया तो जेई मेन में आ ही जाएगा. इवन जेई एडवांस जस्ट यूजेस दीज आइडियाज. जेई एडवांस में कम आता है, जेई मेन में ये वाला ज्यादा आता है. जेई एडवांस में एक्चुअली इवन मोर डायरेक्ट चीज आती है, बट ग्राफ ज्यादा आते हैं. ठीक है. ओह दैट्स ग्रेट वुशांग. इट्स ओके यार, हायर लोअर कोई फर्क नहीं पड़ता है. आप कोशिश करते रहो ना यार. सी whatever you try, right, you will get some rank. कुछ ना कुछ आएगा. Somebody will get rank 1, someone will get 1000, someone will get 10,000, someone will get 1 lakh. कोई फर्क नहीं पड़ता यार. You keep trying your best ना. I know that competitive exams are always about, usually लोगों के दिमाग में about some sort of social ladder, right, कि ये रैंक मिली, ये आपको सब जगह पूछा जाता है रैंक क्या है, रैंक क्या है, राइट. कोई फर्क नहीं पड़ता है. मे बी सोसाइटी वुड केयर, बट आपको फर्क नहीं पड़ना चाहिए. आप अपना यू पुट इन योर बेस्ट एफर्ट. ठीक है. एंड देन यू कीप डूइंग व्हाट यू लाइक डूइंग इन लाइफ. आई थिंक वो जरूरी है. हायर लोअर कोई फर्क नहीं पड़ता है. आप जितना कर सकते हो आप कोशिश करो. हर एवरीबडी हैज देयर ओन थिंग्स दैट दे आर गुड एट एंड यू नो दैट दे वांट टू बी गुड एट. मोर इंपॉर्टेंटली व्हाटएवर यू वांट टू बी गुड एट, ट्राई दैट. इट्स ओके. चलता है. थैंक यू फॉर अटेंडिंग दीस सेशंस. Nitya, can you explain about ions formed? What do you want me to explain, Nityashri? I didn't follow your question. Yes, Rek, absolutely. All right, India. Awesome. That's great. That's great. We're starting revision sessions on Thursday, 11:30 a.m. Mole concept se. Nitya, I didn't follow your question. Can you explain about ions formed? Can you just tell me what you want to know? I'm going to start doing a question, but I'm here to explain whatever, Can you explain what ions formed? Ions formed. कहाँ पे मैं समझा नहीं यार. But let me know, Nityashri, what is it that you want to know? Here is a question. The specific conductance of a 0.01 molar solution of a weak monobasic acid is this. Specific conductance. The dissociation constant क्या होगा? अरे यार ये तो बहुत ज़्यादा डायरेक्ट सवाल हो गया. ठीक है कर लो, इट्स ओके. ज़्यादा डायरेक्ट क्या होगा? यही आता है जेई मेन में, राइट? जेई मेन में दिस इज द काइंड ऑफ क्वेश्चन दैट कम. सो प्लीज गो अहेड एंड सॉल्व इट. Try this out. And Nityashri, please elaborate on your question. I'll try and help you out. By the way, wondering what that weird text is behind me, that is a link to this video itself, right? Like an inception. So in the description, as the session gets over, I'll post the link of this, the Telegram channel pe video hoga. Yes, notes honge. And these notes will have a link back to this channel, because if, for some reason you're like, hey, yahan pe kya bola tha? Likha to kuch hai, bola kya tha, I want to see, you can just come back to this. And yeah, I keep forgetting to say in the starting of the channel, but please share this with your friends and subscribe and all of that. A lot of people are not watching this live. I know this. That's all right. But please do that. That will help us bring this content to you. Sai is saying 1.5. No, 0.5. Okay. Yeah, absolutely. Straightforward. So 0.05. Yeah. Kappa is what? 0.2 10 to 10 power minus 3 Siemens per centimeter. Alpha is simply lambda m by lambda naught m. Lambda m क्या है? Kappa times 1000 by C. और C भी दिया हुआ है concentration. Right, direct is specific conductance, no equivalent, nothing, no business there. 20 by 400 हो गया 0.05. खत्म. Done, right? That's it. That is it. Cool. Okay, yeah, this was supposed to come before this. बाद में आ गया. 0.05 Bhavesh, not 0.5, it will be 0.05. Maybe I think when we did this kappa into 1000 वाली चीज ना, ये 0.2 by 0.01 में मे बी कुछ गड़बड़ी होगी. Cool. So this value is 20 and not 200. Maybe आप जब लिख रहे हैं तो maybe आपसे 200 हो गया. All right. That was it for me today. Yeah. आज का सेशन यहीं पे होता है खत्म. What has the only thing that is left for you to read from NCERT is the whole battery वाली चीज. Please उसको NCERT से पढ़िए. And I will do PYQs. Batteries. Read up. Okay. The reason I haven't done it here is because it's very theoretical and JEE pass mein hai. If I had more time, I'd definitely sit with you and do this in the given time that I had, was given to finish this chapter. But to do whatever theory things before we start the revision stuff, I thought let's just do one chapter probably, and that one chapter was Electrochem. PYQs ka part 2 will be on this weekend, on Saturday, most likely at 6:30 p.m. or something like that, 6:30 p.m. ठीक है? I'll meet you then there. और कुछ आपको डाउट्स है तो प्लीज. It's 0.05. Yeah, exactly. Yeah. About ions formed in previous question. ठीक है. It's okay. Typo होता रहता है. Sure, Nityashri. Previous question कहाँ गया? In this question? Okay. Was this the question you want me to help out on, Nitya? Yeah. So yeah, you can carry on. Rek, I'm done with the session. चलिए आप. Nitya, the ions formed in this. So I think I will just go ahead and tell you the theory फिर से over here. This theory is what is important. Let me fix this. Where is this guy here? Not this theory. इससे भी पहले एक चीज theory थी, right? Lambda not equivalent और lambda not m के बीच में relationship. This, Nitya, Sai. Okay. देखो, lambda not m has some ये वाला idea, right? But lambda equivalent does not have those ideas embedded in them. Why is it? Because नीचे मैं फिर से लिखा हूं, यहीं पे लिखा है, it's right here. This is the expression I was looking for, right? So if lambda equivalent is already considering this n factor wala business, then this expression makes sense. You don't have to worry about multiplying this with the number of ions and all, because देखो, Al to SO4 whole thrice will give me 2 Al3 plus ions and 3 SO4 2 minus ions. That is correct. But in this case, I am going to be adding 2 of lambda, what you call it, of Al3 plus lambda naught plus 3 of lambda naught m of SO4 2 minus. Okay. क्यों? क्योंकि जो वहां पे फैक्टर था, here you have lambda equivalent is lambda m by n factor, or let's write it like this, so it's easier. Lambda naught m is n into lambda naught equivalent. That is why you're doing all this. अगर वो नहीं है तो ये n just takes care of this already. Okay. So here, in fact, will be just, if I were to write these numbers down here, फिर से, right? You have lambda naught equivalent of AQ will be lambda naught this divided by 3 of Al, right? Plus lambda naught of SO4 2 minus. ये तुमको खुद करना चाहिए, ठीक है? But I'm doing your homework for you. ठीक है? So and then you have lambda equivalent of this thing. ठीक है? अब तुम आप उसको क्रॉस मल्टीप्लाई करोगे तो 6 चला जाएगा, तो there will be 6 times lambda naught equivalent of the whole thing will be equal to 2 lambda naught m of Al plus 3 lambda naught m of SO4 2 minus. समझा? ये वही आ गया. देखो ये जो यहाँ पे 2 और 3 नंबर थे, that same 2 or 3 number have come from here, this x and y. And here how do I get 6 यहाँ पे? देखो, in इस पूरे salt का Al2SO4 whole thrice, right? There are 2 Al3 plus, so it has 6 electrons. Okay, this is why lambda naught m is going to be equal to 6 times lambda naught m is going to be equal to lambda naught equivalent. Hence proved. एक और सम कर दिया तुम्हारे लिए. ठीक है, तुम लोग हो या चले गए? जाना नहीं, 5 मिनट बैठ के एक्सप्लेन किया. किडिंग. इज दिस ओके? ये तो थोड़ा सा मैथ था यार, कुछ नहीं था. आई डिड नॉट थिंक दैट इसकी जरूरत थी, तो इसलिए मैंने इसको नहीं किया था, बट इट्स ओके. आई डोंट माइंड डूइंग इट एट ऑल. गॉट इट? ओके साई. What is the other person's name? Was asking Nitya. Did you understand? It's okay if you did not. Ping me on I Teach Chem, and maybe I can explain again. But this is the best I can do here in this short time. ठीक है? Lambda is molar conductivity and infinite dilution, and lambda is molar conductivity at certain dilution and degree of dissociation. Absolutely right, Muskan. 100%. Yes, sir. Cool. YSC. Okay, sweet. Has the session ended? Yes, the session has ended in the next 30 seconds. Should I read NCRT? Yes, Sai, you should read NCRT. Please read NCRT, दोस्तों. You're most welcome, Nitya. If you did not follow this, please try it out on your own. Take an example of Al2SO4 and do this slowly on your own. Or you just check the notes. This should be very doable. I know my board work could be cleaner. Yeah. But just rewatch this last 4 minutes. काफी straightforward है. ठीक है? I have basically written down this in the form of this, and I have written back this in this, right? यही चीज मैंने फिर से लिखी है. Cool. Okay. This expression, by the way, is lambda naught m, and in the end, this is equal to lambda naught m as well. ठीक है? Not lambda naught equivalent. This will be 6 times lambda naught m. All right. सही लिखा था. क्यों मैं गड़बड़ कर रहा हूं? This was correct. This was lambda naught equivalent itself. Okay. All right. Yuvraj, no homework questions because I'm ending the session right now, right? This is the last one. Homework चाहिए तो कर सकते हो, ठीक है. but I won't be able to discuss the homework. Okay, you want homework questions? Hold on. देते हैं आपको homework question. Here is an interesting one. इसका थोड़ा सा, let us fix the, what should I call it? This is slide number 120. एक ही सवाल दे रहा हूं आप लोगों को. I'll try and solve this for you during our PYQ session. ये लो. Okay? Try this out. The hint, you want a hint for this question? Homework question? आप लोग try करो. Since this is a JEE question, you will find solution online आसानी से. If you want a hint, the concentration will come from KSP values. ठीक है? That's the hint. ठीक है? We have done all lambdas in terms of concentration. That will come from the KSP value. You're able to see this right now, right? I hope you're able to see this. इसको मैं unhide कर देता हूँ slide को. There you go. Okay? Lovely India. That's great. Yes, session is over, Arman. हम लोग मिलेंगे. I know I changed the timing of this one. So yeah, apologies for that. Last minute change in time. I'm going to be meeting you guys from now on at 11:30 in the morning for the revision sessions. Okay? On the weekdays. Weekend में as usual we'll meet at 6:30. ठीक है? It's okay, Arman. I know, and it's on me also, right? मैंने भी last minute time change किया. It was supposed to be at 7 o'clock, and this morning I said let's do it. I mean, it's supposed to be 8:30. I made it at 7 instead. So yeah. All right. I'm great, Jayavardhan. How are you doing? चलते हैं. I have another session to take in about 10 minutes, I think. Yeah. चलो. Good night. Have a great. What day is it today? I feel like a time travel. When am I? मिलते हैं आपको Thursday को. We'll start revision sessions all the way from stoichiometry. सारे physical और inorganic के करते जाएंगे. We'll do first couple of sessions of 11th, फिर 12th, 11th, 12th, 11th, 12th alternate करते जाएंगे. ठीक है? If you have any doubts, as always, ping me on I Teach Chem. Share this video with your friends. Subscribe if you haven't already for such awesome content. All right. Good night. See you all. Bye.